Okay, guys, your title is Balancing Equations, and this is going to go on page 26 of your INB notebook. You have different steps to help you with this, and I'm going to explain those in the examples in a minute. Okay, so first, I would write this down. First of all, you have to get your actual chemical names into a chemical formula. So normally I give you word equations. You have to do the crisscross method, the naming that you did before Christmas break. And you have the chemical formulas in a skeletal equation. But for now, I'm going to give you that skeletal equation. That way you don't have to do the naming part, okay? All right, and then your second step is you have to actually figure out how many atoms do you have on each side. How many on the reactant side and how many on the product side. Okay, the only way you can make things equal is by putting a coefficient in front, and I'm going to show that to you in a minute. Okay, go ahead and write this down, and we'll do an example in a minute. Okay, now here you have a few little helpful hints, and I'm going to show you some more of them. So for example, if you have two oxygens on the same side, I would wait that till the end. Also, if you have a polyatomic ion, for example, like here, SO4, let's use a different marker there. Like an SO4, remember that list of polyatomic ions? If you have it on the reactant side and you have it on the product side, you can put it down together on your tally, and I'm going to show you how to do that, okay? Because normally you get the chemical equation in words and then you have to figure out your chemical formula. But for now, I'm going to give you the skeletal equation. Write that down and then make a little list of every single element you have. This is called the tally method. Now guys, out of 28 years of experience, because you can learn it through the tally method or you can learn it through the box method. The tally method, 90% of most students get it this way. It's the easiest way to figure these out, and it's going to be trial and error. Okay, you're going to look at the whole equation and take one element at a time. So what element do you want to start with? Let's start with aluminum. Okay, how many aluminums do you have on the reactant side? Remember, this is your reactant side. This is your reactant side. And this is your product side. So how many aluminums do you have on each side?
1 and 1.
You have 1 and 1. Very good. Why did it do that? Let's do it this way. We have 1 and 1 of aluminum. Okay, how many coppers do we have?
1 and 1.
You have 1 and 1. Okay, very good. Now how many chlorines do you have on the reactant side? You have 2 on the reactant side. And how many chlorines do you have on the product side? You have 3. Very good. Okay, so now, just to refresh your mind, remember you can only have a coefficient in front of every either element or compound. You cannot put it in between, okay, to try to equal this out. So the only thing that's not equal is the actual chlorine, right? Okay, so what common denominator does chlorine have with 2 and 3? I always do something like just 2 times 3 is what? It's 6. Very good. So that means that I can have here, I have 2, so 2 times what would give me that 6? Yep, and so let's do that on a different color. So 3 here, that coefficient changes this side to a 6, because 2 times 3 gives me 6 chlorine. However, when you put a coefficient in front, it not only changes that chlorine, it also changes that copper. So now, how many coppers do I have? I have 3. Very good. Okay. All right, now I have to equal out the other side as well. So how many coppers would I need here? Because I have 1. So 1 times what would give me that 3? Yep, if I put a coefficient of 3 there, it will give me 3. Very good. Okay, now here I have 3 chlorine, so 3 times what would give me that 6? Yep, you put a 2 here, and that gives me 6 chlorines, because 2 times 3 is 6, but that also changes aluminum, right? 2 times 1 gives me how many aluminums? 2, very good. So what do I need over here? 2, very good. And so, whoops, let me put that out. So a 2, I don't have space. Okay, to write that in there. Okay, and so that's gonna, okay, so you're gonna have a 2 here, and your coefficients are going to be, let's put that over here on the side. Your coefficients for that equation are 2, 3, 3, 2. Okay, so now, the last thing you do is look at those coefficients. Can all of these be reduced by one number? Can something divide into all of them? No, right? If I had a 4, a 6, and a 2, all of them could be divided, a 4. All of them could be divided by 2, and you would get this. That would be your most reduced, right? So your most reduced coefficients are going to be what is going to be most correct, okay? All right, what questions do we have so far? None, are we sure? Be positive? Okay. Okay, let's do another example. So first you're going to make your list. What are my elements so we can do the tally? What's my first element over here? Yep, an oxygen. Okay, and you're going to ignore these because this is a picture from something else that is not correct. Okay, and what's my next element? Very good. Okay, and then my last element is hydrogen, right? Okay, now, whenever you have split oxygens, like here, I always wait that to the end. If you do all of your other elements, usually the oxygen will then figure itself out, okay? So let's count the atoms on the reactant side. How many oxygen do you have? How many oxygen do you have? Yep, you have 1, 2. So I have 2 oxygen. How many oxygen do I have on the product side? 2, very good. Okay, now how many fluorines do I have? I have 2 on the reactant side, very good. Okay, now how many fluorines do I have on the product side? I have 1, good job. Okay, how many hydrogens do I have on the reactant side? I have 2. And how many hydrogens do I have on the product side? 1. Okay, so now your job here is to make sure you can equal out everything that you have. And remember, the only place you can put something is in front of the actual element or compound. Okay? All right, so now I would leave oxygen to last. What do you want to start with, the fluorine or the hydrogen? What do you want? H? Okay, so hydrogen here has 2, and over here we only have 1. So what would have to be here to make this one a 2? 1 times what would make it a 2? Yep, so your coefficient here is 2, and that changes your hydrogen to 2 hydrogens. But it doesn't just change the hydrogen, it also changes the fluorine, correct? So 2 times 1 for fluorine, how many fluorine do I have now? 2. Very good. Now, is everything equal? Yes. So that means we did not have to do anything here, so it's going to be a 1. We did not have to do anything here, so this coefficient will be a 1. And we did not have to do anything to the O2, so that will be a 1. So your coefficients are going to be 1, 1, 1, and 2. Now, is this my most reduced? Yes, because the moment you have a 1, you can't reduce that anymore, right? Yes? Okay, what questions do we have? We don't have any questions? Okay, I'm going to give you another one, and I want you to I want you guys to try it yourself. Okay, now don't forget to do your tally. So you have carbon and you have oxygen. So do your tally, and I want you to do this and then tell me what your coefficients are. Okay, I'm sorry, I didn't hear that. What?
1 on the left.
Of the carbon?
Yeah, 1 on the left side for the oxygen.
Okay, and then you have one carbon, so you have 2 carbons, yeah? Okay. And then how many oxygen on the left?
1
You have 1 on the reactant side
and 2.
and 2 on the product side. Very good. Okay. So you're trying to equal out the oxygen because you only have 1 on the left side. So what can I put in front? Because I only have 1. So 1 times what will give me 2?
2.
And you put that 2 coefficient, and this makes your oxygen equal. Yes? But it also changes your carbon, because remember, this whole thing is a compound. So when you change the oxygen, the carbon comes along with it, okay? So now I have 2 carbon, and this is equal. Am I now balanced?
C.
Very good, C. So anything you didn't have to do, because we didn't have to put any coefficients in front of that other element in compound, it becomes a 1. So what are my coefficients? 2, 1, and 1. Very good. And that's it. That's it right there. Okay? Let's try another one. Let's do the tally first. What are my elements? Hydrogen and what else? And oxygen. Very good. Okay. So now what do I do? Remember that these are not it. I have how many hydrogen on the reactant side? I have 2. Very good. How many on the product side? I have 2. Okay. How many oxygen do I have on the reactant side? Very good. Okay, and how many oxygen do I have on the product side? 1. Okay, uno. So now tell me where to put a coefficient. Let's change. On the right. Very good. And so what coefficient am I going to put there? A 2. Very good. And so that 2 times 1 oxygen changes this to a 2. But it also changes who? Yep. Very good. And so 2 times 2 gives me 4 hydrogen. So that means I'm going to have to change this one. Oh, okay. Okay. And so now 2 times what is going to give me a 4 on this side? So you put a 2. That's going to be your coefficient. And that now gives you 4 hydrogen. Now is everything equal? Yes. Good job. So now my coefficients, what do I put here since we did not have to do anything to it? A 1. That's it. You're going to put a 1. So it's going to be 2, 1, 2. Very good. And can I reduce this? Your last question is, can you reduce it? So never be scared. You can have a coefficient of 25 or 18. Never be scared to go to a high number, because in the end, if all of them can be reduced, you can reduce it, and that is your most correct coefficients. Yes? Okay, do we need one more, or are we good? We're good? Okay, you're going to go ahead and go to your worksheet.